So that was the basic introduction, the basic understanding of what we mean by factor theorem, what we mean by remainder theorem. Hopefully you are able to connect them into one idea and even connect it to the roots and solutions and the basic factorization idea. So now just a little more play and practice so that we are clear with the idea. Now we also get settled and consolidated with the material so that it's on our fingertips as such, right? So this is the expression and it is being divided by x minus 1, and the question is what is the remainder. So I will use the remainder theorem that if f of x is being divided by x minus a, the remainder is going to be f of a. Comparing the form is important. X minus a, x minus 1, that means a is equal to 1. That means f of a is equal to f of 1. That means wherever I see x, I have to put a 1. So 1 raised to 4 is going to give me a 1. 1 cube is going to give me a 1. Minus 2 into 1 square is going to give me a minus 2. I'll get a plus 1 and I'll get another plus 1. So 1 plus 1, 2, 2 minus 2, 0. So 1 plus 1, finally f of 1 is equal to 2. That means if you take this expression and take that old long division form and divide it by x minus 1, finally you will be left with a remainder of 2, right? So just a very direct application of the remainder theorem. Just a bigger expression because so far we were using the same expression over and over again. So just to show you that when the expression is bigger, the finding the remainder is much faster using the remainder theorem compared to the long division. And generally just okay, a big idea, small idea, final step taken. What if it was plus 1? So this is where I have to pay attention. Remember my standard form is x minus a. So even if there is a plus 1, I want to write it in terms of the negative. So I will rewrite this as x minus of minus 1. Now this again looks like this. So this time if the story is such, my a is going to be minus 1. That means I will not calculate f of 1, I'll calculate f of minus 1. So just for fun, let's calculate it. Minus 1 raised to 4 even power, that means I will get a positive number. Minus 1 raised to an odd power, I will get a minus 1. Minus 1 raised to an even power, I will get a plus 1, but there is a minus 2. So minus 2 into a 1 will give me a minus 2. A simple plus x, and I need to put a minus 1 instead of the x, and a plus 1. So 1 minus 1 is 0, minus 2 minus 1 is, and this is also 0. So I am left with a remainder of minus 2. So this second extra step, just to make sure that everybody is comfortable with using various basic iterations and turnarounds in the story. And the step is very simple. Bring it down to the form that you are familiar with. In fact, that is why these forms were created, so that you don't have to think all over again. You just compare it to this and then operate the process. Anybody will be able to do it after the explanation. So same idea, just a little more complication in the expression and what we are dividing it with. So first of all, qt, what do I mean by that? If I can write f of t, I can write q of t. It's a function of t and the name of the function is given as q of t, right? Similarly, I can say write p of t, because essentially these are on my own terms for my own convenience, right? For common talking, we write f of x so that the other person will also understand. But let's say if only two of us are talking, I have created a new function, I'm calling it q of t. So that is like a 0 level challenge here. And now the question is, if you take this expression and divide it by this, what is the, and beyond that the question is that okay, this is one expression, and when this expression or equation or function is divided by this one, what is the remainder going to be? So just the terms look like a little different, but otherwise the question is identical. And I want to compare it to my previous story. Remember, I have this f of x being divided by x minus a. All I have to do is find f of a. This is the theory, this is the final summary that I have gathered from my exploration so far. So whatever I have, I want to make it look like this. That is my step number 1, right? So right now, in fact, even this might be confusing. Just simply 2t plus 1. This is being divided by 2t plus 1. Can I rewrite it to look like this? Yes, I can. So let me divide it by 2 because I have a simple x here. Instead of a x, t doesn't make a difference, but the 2t shouldn't be there. So I'm dividing both the terms by 2. So I will get a t and I'll get a plus 1 by 2. Okay, great. Better, but still not looking like this. I want a minus, but I have a plus here. The fraction is okay, I can deal with this. A is equal to half. That I can adjust in my memory bank easily. But how do I make it look like this? T minus minus of half. So these are the only kind of things that you have to pay attention to. So the question, sorry, this was P of t. So the question, just a complicated way of asking the same question as the previous example, but adding more layers of flowery language. Q of t divided by P of t, what is the remainder, etc. But P of t is nothing but t is equal to t minus 1 by 2. And I see it's the same thing. There is a function, it is being divided by x minus a. I have simplified it, right? So that means all I have to do is find q of minus 1 by 2. That means wherever I have t, instead of that t, I'll put a minus 1 by 2. I will not calculate it. I will leave the final value calculation up to you. I'll just put the expression on screen. 4 into t cube, 4 into minus half cube. Plus 4 into t square, that means 4 into half square. Minus t, that means a simple half. A minus half, right? And a minus half here. Remember, so this is exactly the kind of error that you need to kind of avoid. Just pay attention to the process. And then I have a minus 1. The final value, what is the value? I will leave for you to calculate, right? So the same game, just it looks more complicated, it looks slightly different. So that is again a step number 1, step number 2 in the process, that okay, if something new is given, can I make it look like to something that I'm already familiar with, and then run the process as such. So for some of you, you have had enough practice in school, you might have put in some real effort then and there only. But now you will notice that okay, you know the idea. Now what is the difference between knowing the idea and real math skill? This is a little extra level of practice. This is just to make sure that okay, we can play with all the iterations. X plus 1, I have to make everything look like x minus a. So x plus 1 is x minus of minus 1. X minus half, no problem, a is just a half. Just a x is nothing but x minus 0. So now I am making a equal to 0. X plus pi, that means x minus of minus pi. What difference does it make what I am putting here? So x minus minus pi, and the question was basically if this expression is divided by these expressions, what is the remainder going to be? So I'm using the same theorem, we are already familiar with it. That means everywhere I have to plug in a minus pi cube, and not a cube but just a minus pi. Instead of the x, again I will write a minus pi and a square. Now a minus square becomes a plus, or a minus cube becomes a minus. That is again little bit of fundamentals, I'm assuming everybody knows. And then plus 1. So the language keeps changing, but our basic goal remains the same. But it is important to play around a little bit. For example, this looks different, and that is the first level of challenge for beginners. That okay, I know when x minus 5, I know how to operate it, but this looks different. Don't worry, turn around the process. So this is 2x plus 5. Now first of all, I will divide both the terms by 2. Why? Because I want to make it look like this. So I will get a x plus 5 by 2. And then I can rewrite it as x minus of minus 5 by 2. Right? So step by step, question by question, example by example, your process gets better. Some of you have already invested in this process earlier. If you haven't done so, please make sure that this basic level practice or clarity is always there. And it's just or just understanding that okay, I know all possible scenarios, and they should not deter me, because this wasn't like a big step. It was just okay, I have this challenge, what do? I do this, and it gets worked out. So no need to memorize also, just familiarity. So simple question, still staying with the same factor theorem, remainder theorem, same idea. This is the expression, is x plus 2 a factor of this equation expression? So compare it to x minus a, and I can rewrite it as x minus of minus 2. So which gives me a, that means what I have to input in the equation is a minus 2, not a 2. That's the only thing that I have to be careful about. So f of minus 2 or the value of y when you put x as minus 2, because that's the kind of vocabulary that we have already worked together on, right? So minus 2 and a cube gives me a minus 8. A minus 2 square gives me a plus 4. 3 into 4 will give me a overall plus 12. A 5 into a minus 2 will give me a minus 10. And then I have a 6. So minus 8 plus 12 gives me a 4. 4 plus 6 gives me a 10. And a 10 minus 10 gives me a 0. Oh, great. That means this suddenly also tells me that x plus 2, forget about finding the remainder, is a factor of this expression. So what we are moving towards now is essentially connecting factorization. We've already looked at basic factorization, but now connecting it to this factor theorem, remainder theorem. That means once I know this is a factor, and remember this is a complicated compared to our quadratic, slightly more complicated looking expression, but I know one of the factors now. And how do I know whether it's a factor or not? I checked minus 2, it worked out as 0. That means maybe in the beginning I will try out a few simple values, see where am I getting 0, at what value of x am I getting 0. Once I have that, that means that is a factor, that means I get a single factor. Once I have a factor, then maybe I can find the other factors. So let's try the same for this example. You worked it out and you saw that x plus 2 is a factor in this story. That means the same expression can be rewritten as x plus 2 into something. If I tell you that for 15, 5 is a factor, what does that tell you? That 15 is equal to 5 into something. I know it's 3, but a factor means a number which completely divides the other given number, or a factor is a number which when multiplied by another number gives you the original expression of the number, right? So again, something that we've covered earlier. So x plus 2 is a factor, I know that. I want this x cube plus 3x square plus 5x plus 6. So let's try and make it and see how we will come to that point. And right now we are doing it completely manually. Later we will learn a shortcut also. Again, it's better to just do it manually because the shortcut may or may not always work, right? So x plus 2, I want an x cube, okay? I have an x. What do I want? I want an x square. So x into x square will give me an x cube, not a problem at all. And what I'll get is a 2 into an x square. That means if I multiply so far, I've got an x cube, and this into this will give me a 2x square. Great. What I want was a 3x square. That means I have already got 2x square. I want one more x square extra. How will I get it? Let me add more terms in the story. What do I want? I want one more x square. So let me just throw in a single x. In case this is not making sense right now, once the story is complete, it will make sense. Then rewind and watch it again, right? So x into x square gave me an x cube. X into 2 into x square gave me a 2x square. So x cube I have covered. I wanted a 3x square. I have already got a 2x square. That means I want one more x square. How will I get it? X into an x will give me an x square. Great, not a problem. So 2 into an x, what I'll also get is a 2x. What I want is a 5x. Remember, this 3x square is also taken care of. What I want is a 5x. That means I want an extra 3x. How will I get a 3x? Let me throw in a 3 here, because remember day 1 or day 0 multiplying polynomials, and this is the same process running backwards, right? So x into 3x will give me a 3x, and now last step I don't even have to take. 2 plus 3 will give me a 6. So because I knew x plus 2 is a factor, I could factorize this expression into these two parts, right? So I hope the idea how the factor theorem, the remainder theorem, or very simply finding where is this expression going to be equal to 0. That means for what value of x this is going to be 0. In this example, I already given you a hint starting with this division. So we figured out that minus 2, the whole expression is 0. At minus 2, the whole expression is 0. That means x plus 2 is a factor. So I took x plus 2 out, and I'm trying to recreate this expression. And just thinking, I have a x plus 2. What do I need to multiply to get to an x cube? And I'm thinking one step at a time. X into x square gives me an x cube. Then because of the laws of mathematics, I have to multiply this. So that's why I got a 2x square. But I wanted a 3x square. So then what I did, you can always rewind and look back, right? But right now, as of now, again, in your notes or examples, you will further find the same process explained using more and more examples as such. So this is just an introduction in terms of how the factor theorem, remainder theorem connect to the idea of further factorization. If you have a complicated looking expression like this, where you will not be able to see the product and the sum directly and quickly, you might have to find one root, you have to find one factor, take it out, and then simplify the other part, which may make your life easy as such, right? But later, again, we are almost reaching mastery here in terms of simply multiplying and maybe some factorization also. As you move into more complicated areas, you will see that this is just a part of the process. But later the higher levels are actually easier once you are okay with multiplying, dividing with basic terms, factorization, input, output, what is the root, what is the solution, etc. The basic connections between all of these terms, right? So this is an entry into factorization again.